Hello, this is Axiom Ledger, an append-only event-sourced infrastructure that makes every agent action cryptographically traceable, temporally queryable, and architecturally auditable. Um, for this week's standard challenge, it's show me the complete decision history of an application of IDX from submission to final decision. So yeah, as we can see, every event type is present. From AJAX context loaded, application submitted, credit analysis completed, for screening completed, compliance ruled, etc. If we look at the CORR, it's the correlation ID, trying to tying the entire loan life cycle to a single business transaction. The cause field shows the causal chain. Credit analysis completed was caused by application submitted. Decision generated was caused by credit analysis completed. Human review completed was caused by decision generated. The entire decision trace is cryptographically linked. And the integrity check, the chain valid true. Tamper detection false. 5 events verified with SHA-256 hash chain. And now we will run the MCP lifecycle test. So the MCP lifecycle test drives every step: start agent session, submit application, credit analysis, for screening, compliance check, decision human review through the MCP tool call only, no direct Python, exactly how a real LLM agent would interact with the system. Following that, we can run the confidence flow test. So the caller sends a confidence of 0.45 and tries to approve. The aggregate overrides it to refer. The LLM cannot bypass this. It's enforced in the domain logic, not the API layer. For concurrency, say two AI fraud detection agents simultaneously process the same loan application. Both read the stream at version 3, both called append with expected version 3 without optimistic concurrency control. You get a split brain, two fraud scores, no authoritative state. But let me show you how our system handles it. So in our system, exactly one agent wins. Fraud agent A appended at position 4. Fraud agent B received a type optimistic concurrency error, not a string, a structured object with the stream ID, expected version, actual version, suggested action, and reload stream and retry. So for the temporal compliance, the 3 events with the real timestamps have happened, as you can see. The rule that passed later does not appear in an earlier snapshot. That's a temporal guarantee. So the resources, the application ID, compliance as of the timestamp, it reads from the projection table, never replying aggregate streams. Okay, so upscale immutability, event source sourcing call guarantee. The past is immutable, but the schemas evolve. As you can see, there are 3 steps. One is write a v1 event directly, old schema, no model version, no regulatory basis. 2 is load it through the event store, load stream, comes back as a v2 with a model version, credit active, year 2026, and regulatory basis, inferring the fin 2026 rule package from the event timestamp. And 3 is reach into streams and read the raw stored dictionary. This is in memory equivalent of select payload from events where stream ID equals dash 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 and stream position is equal to 0 against the PostgreSQL events table. For fields we generally cannot infer, like confidence score. On historical events from before we tracked it, we will return null, not a fabricated value. The design.md document tells exactly why an incorrect inference has a quantifiable downstream consequence. Null is like honest, fabrication is a complete liability. So there are 7 upcasting tests passing, including the timestamp based inference from v1 to v2 to v3 chain, and no opguard for events already at the current version. And for the gas down crash recovery, on crash, every agent action is written to the event store before it executes. Then on crash, a new agent instance replaces its session stream to reconstruct context and resume without redoing the completed work. So like in scenario A, had the crash, we appended 5 agent sessions events, agent context loaded, then 3 agent node executed events, load documents, compute ratios, etc. Then we drop in memory agent objects entirely, simulating a process kill. We call construct agent context. Yeah, we call the reconstruct agent context for scenario A. Scenario B, decision generated was written with no corresponding human review completed. Status is need reconciliation, not just failed. Specifically, the partial decision boundary violation. The pending work message names the missing event type exactly. The agent cannot proceed to approval without resolving this gap. This is detected at the boundary level, not in the event data, buried in the event data. And scenario C, the session ended with the agent session failed and no recovery event, so status is failed. Pending work shows resolve agent session failed, LLM timeout error, 3 distinct cell status, each enforced automatically by a reconstruction function. And finally, the what if contrafactual plus clause. What would the final decision have been if the credit agent had returned risk tier high instead of medium? This is not like a hypothetical exercise. Regulators require it for model audits. So the what if projector loads all relevant events up to the branch point, credit analysis completed. It injects counterfactual events with a risk tier high instead of a medium. It then continues replaying real events that are causally independent of the branch. Events whose causation ID doesn't track back to the substituted event. So events that are causally dependent, like decision generated, which were referenced in the original credit session and are skipped. So the result is a real outcome, approve versus counterfactual outcome refer. The confidence floor rule cascades, no counterfactual events are written to the real score. Live database is untouched. And finally, the regulatory examination package, single JSON file, the complete event stream in order, projection status at the maximum date, audit chain, integrity verification, a human readable narrative generated by replaying events, and every AI agent's model version and input data hash. So a regulatory can verify the package's independence without trusting our system. We can see the full test here. So all 66 test cases passed, and the skipped ones are related to the Postgres, as I mentioned earlier.